Welcome to our comprehensive guide on multimedia communication, tailored for BEB Tech students preparing for their exams. In this video, we'll walk through the core concepts, practical applications, and essential exam topics you need to know. Multimedia communication blends text, images, audio, and video to enable rich interactive experiences. Whether you're aiming to understand the basics or master advanced topics, this guide will help you connect the dots and build a strong foundation. Let's start by exploring the fundamental networks and applications that drive multimedia communication. Broadcast television networks and ISDN are foundational to multimedia communication. Broadcast TV networks distribute content to a wide audience using radio waves, while ISDN, or Integrated Services Digital Network, allows digital transmission of voice, video, and data over traditional phone lines. ISDN's ability to carry multiple signals simultaneously made it a key technology before broadband became widespread. Understanding these systems helps you appreciate how multimedia content reaches users, whether via traditional TV or digital networks. Next, let's see how interactive television applications work on both cable and satellite networks. Interactive television applications have transformed how viewers engage with content. On cable networks, interactive TV allows users to select programs, access on-demand content, and even participate in live polls. Satellite networks offer similar features, but with broader coverage, making interactive services available in remote areas. These applications rely on two-way communication channels, enabling real-time feedback and personalized experiences. As multimedia evolves, interactive TV continues to bridge the gap between traditional broadcasting and digital interactivity. Now, let's dive into the different modes of communication with a visual overview. Communication modes define how information travels between sender and receiver. The main modes include simplex, half-duplex, and full-duplex. Simplex allows one-way communication like TV broadcasting. Half-duplex supports two-way communication but not simultaneously as seen in walkie-talkies. Full-duplex enables simultaneous two-way communication such as phone calls. Each mode has its own use case in multimedia systems, affecting speed, efficiency, and user experience. Understanding these modes is crucial for designing effective multimedia networks. Next, let's calculate propagation delays in different communication channels. Propagation delay is the time it takes for a signal to travel from sender to receiver. It depends on the distance and the velocity of the signal. For example, a 1 km private telephone network connection, 200 km ISDN link, and a 5000 km satellite channel each have different delays due to varying distances and signal velocities. Calculating these delays helps engineers optimize multimedia communication for real-time application. By understanding these principles, you can ensure smooth transmission of audio, video, and data across networks. Now let's move on to how text is represented in multimedia. Text is a fundamental element in multimedia, represented in various ways such as ASCII, Unicode, and markup languages like HTML. ASCII uses 7 or 8 bits to encode characters, while Unicode supports a vast range of global scripts. Markup languages add structure and formatting to text, making it suitable for web and multimedia applications. Understanding these representations ensures compatibility and accessibility across platforms. Next, let's explore the raster scan principle, which is key to displaying images on screens. Raster scan principle is used in both televisions and computers to display images. It works by scanning the screen line by line from top to bottom, refreshing the image many times per second. This method creates smooth visuals and supports high-resolution graphics. In televisions, raster scanning synchronizes with broadcast signals, while in computers, it's managed by the graphics hardware. Understanding raster scanning helps you appreciate how multimedia content is rendered on different devices. Now, let's calculate the time needed to transmit digitized images at various data rates. Transmitting digitized images involves calculating the total data size and dividing it by the transmission rate. For example, a VGA image 640x 480x 8 bits and an SVGA image 1024x 768x 24 bits require different amounts of time to send at 64 kbps or 1.5 mbps. This calculation is crucial for multimedia applications like video streaming, where bandwidth and speed impact user experience. By mastering these calculations, you can optimize multimedia delivery for various network conditions. Next, let's look at how digital cameras and scanners capture and process images. Digital cameras and scanners are essential tools for capturing and digitizing images. A digital camera converts light into electrical signals using sensors, processes the data, and stores it as digital files. Scanners work similarly but capture images from physical documents or photos. Both devices use components like lenses, sensors, and processors to ensure high-quality image capture. Understanding their block diagrams helps you see how multimedia content is created and prepared for communication. With this foundation, you're ready to tackle more advanced multimedia coding and compression techniques.